Hello everyone, welcome to this video on the classification and the evolution of galaxies. My name is Suyang Zhang, and this is my student card. And the ID is the 5448651. Today we will learn together how to determine the type of galaxies through their images and what information these images can tell us about galaxies' evolution. In this experiment, we will find that, based on the color, shape, and structure of a galaxy, we can determine whether it is young or old, whether it still can form new stars, and whether it has experienced collision or mergers. Next, let's analyze some images of galaxies and see what amazing things they tell us about the universe. First, let's look at the Comet cluster and Hercules cluster. When we zoom in and closely observe these images, the most obvious feature is the color difference between spiral galaxies and elliptical galaxies. Spiral galaxies show blue light, indicating that they still contain gas and are constantly forming young hot stars. Elliptical galaxies often appear reddish, showing that their star formation activities have slowed down or even stopped. And the stars inside are mostly older and cooler. In the same spiral galaxy, we can also observe this age difference. The central bulge is more reddish because it's where old stars gather. The outer disk is bluish because it's the area where young stars are forming. These color features enable us to determine the age and activity status of galaxies without using any complex instrument. Next, let's take a look at the colliding galaxies NGC 6745. In this picture, we can see the extended tidal tail structure and some bright blue areas distributed on the outside. These blue areas represent newly formed stars, which are the result of gas compression caused by the collision of galaxies. Galaxy collisions are extremely violent events that can put galaxies, distort their structures, and cause intense starbursts. Over time, these galaxies may also gradually merge into large systems. NGC 6745 is a typical example. When we classified the galaxies in the selected cluster images, we selected 20 galaxies in each image respectively. A very obvious trend will be observed. Most of the galaxies in clusters are elliptical galaxies because the environment of galaxy clusters are very dense. Galaxies will experience more gravitational force and mergers, causing them lose gas earlier, evolve fast, and finally present a more agent, redder, and smooth appearance. These classification results indicate that the environment has a decisive influence on the distribution of galaxy types. And to study galaxies in an earlier universe, let's take a look at the Hubble Ultra Deep Field. The light from these distant galaxies takes billions of years to reach us. So HUDF shows us an irregular when galaxies are still very young. And in this picture, many galaxies are very small, irregular, and even present fragment shapes. When we compare these early galaxies with the older and smoother ones in the galaxy clusters, a clear evolution trend can be seen. Galaxies usually start in an irregular shape, gradually develop into spiral galaxies in an orderly manner as their structure progresses, and finally evolve into elliptical galaxies after multi-mergers and gas depletion. If we could observe HUD5 up to 10 billion years ago, the current irregular galaxies might have merged into large systems. Spiral galaxies become rarer because they stop star formation. The number of elliptical galaxies will increase. Finally, this is the information I have cited. The links of the pictures have been placed below each picture. By analyzing these galaxy images, we can see that the colors and structures of galaxies contain rich information. We can identify which galaxies are young, which are old, and which are experienced intense interactions. By observing galaxy cluster and HUD-F, we can gain a clear understanding of how different environments and different cosmic periods influence the form of galaxies. These images bring young galaxies, merger galaxies, and colliding galaxies together, allowing us to understanding the evolution process of galaxies in an intuitive way. Thank you for watching. Bye.